Hello and welcome to Telematics, our master level course for everything that covers computer networks, the internet, all the applications, a bit more the advanced topics. So we expect you to know basic technologies like TCP/IP and how the internet works, what protocol stacks are. In this course, we'll cover a bit more the advanced topics. So what is the next upcoming protocol? What are the new applications? What are the challenges? What are the problems? What are new solutions for this? So the whole course is organized following the flipped or inverted classroom principle. So I will prepare videos for all the different chapters, and I expect you to watch the videos, try to understand the content, try to answer the questions, because I split up the content into small subsections, and all the subsections, they end with a short questions and some tasks for you. Try to answer them, and during the lecture, we'll go through all the questions and the tasks and discuss them. So now, that's the last time you will see me, and now let's focus on the content, and let's start with the first chapter. Welcome to our first chapter of Telematics, the general overview and the introduction, some content. So, why is this course called Telematics at all? Well, telematics, that's a quite old term. That's basically telecommunications plus informatics. That was an initiative in Europe many years ago, 1978, when this term was coined. And this basically means that we bring together the telecommunication world and the informatics computer science world. So you will find similar courses known as computer networks or advanced courses in computer networks. So what is the focus of this course? Well, we will discuss how we interconnect devices, and in the end also people, discuss many different aspects of communications, all the challenges, all the difficulties, and, well, last not least, the applications on top. Well, basically we will start with the applications because this really motivates why we need such a course. So, well, if you think of telecommunications and computer science, think some years back during the pandemic. Well, I bet you all would agree that computer communication really makes our life much easier. Think of all the online courses, the tele-teaching, whatever, replaced many courses by these online courses, and we installed a lot of video conferencing systems, etc. And as you can read, so the COVID-19 makes it clearer than ever, access to the internet should be a universal right. And indeed, if you have a connection, you can participate in whatever course of this planet. So, big advantage. And many people really think, yeah, the virus changed the way we use the internet. Many people in administration suddenly, yeah, they could accept digital signatures and emails, etc., and not paper anymore. So it makes our life easier. I guess you all agree. Is it really the case? So we will also discuss in this course, so what happens if we have an outage? So we experience big outages on Facebook, WhatsApp, Instagram. Millions of people rely on this. And now, what do you do without these services? So for many people, Facebook or whatever, WhatsApp, this is the internet. We will discuss this is not really true, and I will show you many of the protocols under the hood. So what drives the internet? What are the real challenges? But these are very famous applications. So does it make our life easier? We can discuss this if social networks are really the ultimate goal of the internet. But okay, major applications. But when we discuss the internet, and if we look at these types of applications, and then maybe some weeks from now we'll discuss some of the protocols, you will think back and say, okay, this is the way we designed the internet. We will learn a lot more about this, and this is how we use it. And then you will understand why today this is not the original internet alone. We have many services with real major dependencies. May it be from Alpha, Amazon, Apple, Meta, Microsoft, whatever, and all the services. So this is not the ultra robust, whatever basic idea of the internet, but we rely on many, many services. And what happens if those services are not available anymore? I will give you an example in a second. So even without any attacks and hacking and whatever, we pretty much depend on many services. Think of the example, WhatsApp is down or Facebook is down, whatever, and many people are stranded. Somehow they don't know how can we access anything, how can we buy things, how can we look up certain topics, etc. There are many, many more dependencies, not only related to communication. Think of chip manufacturers. So what happens if there is a problem with the chip manufacturer? So we rely on these as well. So hardware, many more dependencies. We'll discuss this from time to time when it comes to critical infrastructures like photovoltaics, for example. We need communication for the photovoltaic systems to actually be useful, because without communication, we cannot use the power generated by those systems. So we have to communicate how much power we actually give to the power grid, etc., etc. And then talking about communication, if you really want to see the final killer for all the communication systems, watch this video. It will tell you a bit more about solar storms and how solar storms can kill immediately all the communication systems worldwide. Okay, horror scenarios, I admit it. But let's go back to these dependencies. One example just some years ago showed, we're pretty much dependent. We don't know that we depend on certain services. Why? Because it's so convenient to use certain web services, for example. So, okay, I need a certain service. Oh, is something available? Oh, yeah, there's a web service available. So let's grab this and let's then build my small, medium, whatever enterprise on top of this. A simple typo back in 2017, caused the damage of whatever estimated $150 million. It was just a typo, causing an outage at Amazon. And people said, okay, it's kind of terrifying how much of the internet is down because of an outage in one of the web services. This is not the internet. That's just an application, or precise, and service on top of the internet, a service used by many, many applications. But we rely on this. So we will learn how to distinguish between this is the internet technology, and then we have certain services on top of this. So there was still the internet up and running, doing pretty fine, but we had a problem with one of the services. Okay, we'll discuss this. So think of this, we have many, many of these interdependencies. Why do we use the internet? Well, because we have so many great services on top of it. And if you look at the numbers of uses of devices, billions, we don't know exactly how many, 30 billion, whatever devices connected to the internet, and exabytes of data exchanged each month, hundreds of exabytes of data. So that's quite a lot. These are all just rough estimations. We don't know the precise number because there's so many corporate networks we cannot look into. So very rough estimations. Okay, so it's important. You see, we depend on it. Many services, many devices connected. So what else is the motivation for this course? Okay, let's have a look at one of the prominent examples of a application, YouTube. 100 million hours of video uploaded each day. Okay, and it's already quite complex to transmit data, maybe a bit more complex than you think. You may know the basics of the internet. Well, actually, that's a prerequisite for this course. But we will have a closer look how we really transmit data, how we access many different services from a single host. How do we separate the services? How do we maybe support different quality of service for these different services? You can imagine that maybe email, well, you're a bit more delay tolerant. A YouTube video? Maybe not, because now I click on the video, I want to see it immediately. Email, well, 20 seconds later, who cares? So there are some differences in quality of service. We'll discuss this. And then, well, in particular, how do we achieve scalability? One computer? Well, that's quite easy. But what about millions of computers accessing servers, many servers, server farms, grids, clouds? What about cloud computing? What about edge computing, peer-to-peer networks? So we'll clarify all these terms during this course. So if you think of this, well, this is not that simple anymore. Do we have priorities, different applications? How do we multiplex this over a single fiber or copper wires, or what is multiplexing at all? How do we achieve this? So we will have millions of devices, users accessing, for example, the mail or search engines or videos. But we can try to scale even more. Think of the Internet of Things. So we have billions of devices that are somehow connected. May it be smart vehicles, objects, animal tracking surveillance systems, or smart energy grids, building automation. So modern buildings, they have thousands of sensors installed in the buildings. Smoke detectors, open windows, door detectors, whatever, embedded systems in all these, in chemical plants, in healthcare. So all the devices are connected somehow, creating smart hospitals, supporting telemedicine. We have smart cities, at least we have the ideas of smart cities. And you can integrate those devices into everyday things. We have many machines talking to other machines. So this is really scalability. We have billions of devices. We don't know how many, but you can be pretty sure it's billions. And what makes it quite interesting, that we use one basic technology for many different purposes. One basic technology bringing all these systems together. For good or bad, we will discuss the good. That means we can access sensor values across the internet. We can exchange a lot of data between the devices. We can apply artificial intelligence to all this to get some certain information out of these systems. So many good ideas, but also for the bad, the dark side. We can access, we can attack those systems. So the most powerful distributed denial of service attacks, they use thousands, millions of these simple devices to remote control them to attack a victim. So for good or bad, we use the same technology for many, many, many different things. So quite interesting. Okay, so I will conclude all these small subject sections with a questions and tasks slide. What is the idea behind this? You should get involved. You should be active. For example, check out the new statistics. As soon as you integrate statistics into a course, they are outdated. So use, for example, pages from Statista or whatever, and checking what really drives, for example, the internet of today. Is it typical application or typical usage scenario, humans, machines, whatever. Start thinking of further interdependencies. In particular, think of critical infrastructures. That means banking, insurance systems, water supply, gas, power grid, traffic systems, communication systems. So they are all interconnected. They all use communication networks. So what happens, for example, if you have a blackout? Oops, what about your communication network? How long will it survive in a blackout scenario? Or if communication is down for some error in routers, we'll discuss many possibilities for problems. What happens to the power grid, to our smart buildings, to our smart cities, etc. And then think of what can be done to counteract major dependencies. So do we have a structural problem in our networks? So what can you do there?